po tayong lahat, ilagay ang kanang kamay sa ating dibdib at sabay-sabay nating awitin ang pambansang awit ng Pilipinas.
Bayang magiliw, perlas ng silanganan, alab ng puso, sa dibdib mo'y buhay. Lupang hinirang, tuyang ka ng magiting, sa manlulupi, di ka pasisiil, sa dagat at bundok, sa simoy at sa langit mong bughaw, may dilagang tula at awit sa paglayang minamahal, ang kisap ng watawat mo'y tagumpay na nagniningning, ang bituin at araw niya kailan pa may di magdidilim. Lupa ng araw ng luwalhati pagsinta, buhay langit sa piling mo. Aming ligaya na pag may mga api, ang mamatay ng dahil sa'yo.
Hi mga ka-circle, good evening. So reminder, please register now through the link http slash http://rec.org.ph/element6june12 reg or scan the QR code on your screen. So this will be a prerequisite for your e-certificate. We are now live via Facebook. facebook.com/rec.org.ph/live and to our YouTube channel, youtube.com/radio engineering circle. And if you have any questions, you can type it on the comment section of this live webcast as we will have an open discussion at the end of our speaker's talk. Again, just a reminder, the link is open until 8:30 p.m. only, so don't forget to register. Good evening, everyone. We would like to welcome you all to the part 1 of our Propagate and Radiate free amateur radio orientation webinar with the topic of Element 6 Circuit Components. It is one of our countless webinars that will bring you knowledge beyond the horizon and will bring enrichment to your wisdom. This webinar is brought to you by Radio Engineering Circle. I am Christine Bendo. Hi, a regular member of the Circle and also a the link or through the QR code, which is on your screen or you've seen it a while ago. But don't forget to register. You need to complete the registration and mock exam of the three elements episode. We highly encourage everyone to listen attentively to the speakers because later after the presentation, we are going to have a mock exam, which will be the prerequisite to your certificates. In order to get the certificate, you should be able to pass the mock exams of Element 6. Also, we would like to invite you to join our circle, Radio Engineering Circle Incorporated. Just log on to rec.org.ph/join to apply. We are a proud member of Philippine Amateur Radio Association and Federation of Rapid Emergency Telecommunications Team of the Philippines. So I don't want to take much of your time. To start off, our opening remarks will come from a licensed professional electronics engineer and the chairman of Radio Engineering Circle Incorporated, Engineer Gerhard P. Tan. Oh, I would like to correct. I've mentioned a while ago that this is the part 1. Correction, this is actually the part 2 of our webinar series. We are still waiting for Engineer Gerhard Pitan to give us our opening remarks. And I hope everyone is excited because our speaker for today is actually a very energetic and Actually, I am surprised to see his background, and I'm excited as well for his webinar today. And I hope you are too. So while we are waiting for Sir Hard, um, Sir Hard, okay. So again, don't forget to register. We are receiving a lot of requests before on our previous webinars to extend the registration. But again, we are reminding you that the registration for this webinar is until 8:30 p.m. only. So don't forget to register. We will flash again the QR code and the registration link on your screen. So don't forget to register. If you are not registered, you can take the mock exam, and that is a prerequisite, okay, for your e-certificate. Don't forget to register. Can we flash again the QR code and the link for those who just joined us right now? Okay, so our link is rec.org.ph/element6 2021 REG. And you can also scan the QR code that you are seeing on your screen. Okay? Don't forget to register until 8:30 p.m. All right? We all want you to be able to take the mock exam and get the certificate. Okay? All right. Okay, it seems like yeah, I mentioned before that I'm very excited to introduce our speaker for today. So, oh, again, I have a reminder again about the examination. So our passing rate is approximately 70% of the total score, or at least 18 correct answers out of the 25 questions. Again, 70% of the total score, or at least 18 correct answers out of 25 questions. You can only take the Element 6 mock exam until 6 p.m. tomorrow. Please finish the webinar so you can view the mock exam link. Okay? All right. I think it is now the time to introduce our speaker, and I hope everyone's ready. He is a licensed electronics engineer and currently the chairperson of the Electronics Engineering Department at University of St. Louis Tuguegarao. He is an active chapter officer of the Institute of Electronics Engineer of the Philippines Incorporated, ISEP, Cagayan Valley chapter. Also, he is into electronics consultancy and systems design. Aside from being a teacher, he is into Facebook and YouTube vlogging. So he's a vlogger, guys. And we want you to invite to watch and subscribe to his blogs. And actually, madami to. So without further ado, let's all welcome the young and energetic engineer Ariel Lorenzo. Engineer Ariel, hi!
Hello po, Ma'am Christine. Thank you po. Dahil pa-vlog pa talaga. Sorry po
Hi,
kung may
sir.
background. Sa apartment po ako. Hi, Ma'am. And of course,
Yes,
hi
sir.
sa
I'll
ating
give
mga
the floor to you na
participants po dito.
po. Excited na
Sure
po
po,
ang
Ma'am.
ating mga ka-circle na marinig ang inyong webinar for today.
Yes po. Thank you po. So I'm going to share naman my PowerPoint po. So, ayan po, Ma'am. Okay po, nakikita po yung PowerPoint ko, Ma'am? Hello po.
frequency po.
Nakikita po, ma'am?
Yes, sir.
Electronic circuits. So hello po everyone. So as what ma'am had mentioned, I am engineer Ariel M. Lorenzo, and Sir Hard was the one who contacted me to be the one who will discuss the topics for today, which is in the element 6. And then they had given me this course outline. So the physical appearance and types, the characteristics, and the applications with the schematic symbols of the following. So there are many topics that had given me, but I chose only these 8 wherein I can discuss to you because we only have, I think, 2 hours to discuss everything. And in college, this will take 1 semester to teach. No, so I just want to give to you some concepts about these topics. And I know also, I was informed that we are not all in the field of electronics here in the house. So I'm going to make this one comprehensive and then easy to understand. Hope I will make this light. No? So first thing is that what is electronics? So electronics, this is the branch of science that deals with the study of the flow of electrons and of course and their effects in the vacuum gases and in the semiconductor materials. So what do we mean by this? So unlike in the electrical guys, unlike in the electrical, they are into the production of current, no? While us or the production of the yes, enough current, and then while us in the electronics, this is in the study of the flow of electrons. So in your equipment, in your gadgets, there are many components, there are electronic components, and then how electrons flow in there, that is electronics. And then of course, we have the many applications of electronics. First is the aerospace industry. In the aerospace industry, guys, most of the parts used in the space shuttle, the satellite power supplies, the aircraft power management, and other communication instruments, these are all electronic devices. Even in commercial airlines, there are numerous electronic devices which are used to measure different physical parameters like the humidity, the temperature, the pressure, the elevation, and etc. More thing, kaya yung iba maraming nag-apply into, sabi nila pag tawag nan pag ECE ka, electronics, you are inclined in electronics, pwede ka sa mga sa mga related to aerospace, aeroplano and the like. Next is the medical. Of course, in medical nowadays, di ba, we are upgrading. Instead of having an operation to open your heart, just to check, di ba, open your body, ngayon, kahit maliliit na lang na aparatus, tayo nang i-check yung sa loob-looban ng ating katawan, that is because of electronics. To hear the heartbeat of the heartbeat, of course, di ba, we have the ECG, the electrocardiogram, and then by using only sensors, we also have the one that can study the cycle of our brain cells. Okay, that is, we have the EEG or the electroencephalogram or anything that is related to digital signal processing. So that is in medical. Moreover, we also have the automobile or the automobile. These are used in road vehicles. No, electronics are also used in road vehicles, such as in the lighting system of the car, the telematics, in-car sound systems, and more. Initially, electronics were used in cars to control engines. Nowadays, almost everything are controlled using electronics, whether it's a chair in car or speed limitation in car or gas management in the car. We also use we apply also electronics in the commercial. Electronic devices and gadgets are widely used for the commercial purpose, such as telephone, air conditioning, the heating, digital advertising, power supplies, the personal computer that we are using, especially now that most of us are work from home. So gamit na gamit ang ating mga computers, no? The MP3s, the office equipment, the light dimmer, the UPS or the uninterruptible power supplies, and many more. So These are the applications in the commercial industry, and of course we have in the agriculture. So dati mano-mano lang lahat sa agriculture. Now marami ginagamit na rin natin ng electronics in the agriculture, like e-agri sensors, the electro-agri sensors, and the other electronic gadgets which are used for measuring the salinity of soil. Ito yung mga usong-usong research ng mga students in the undergrad, wherein they look for the salinity of soil, the moisture level, and the nutrition level in the soil, yung KPL. And of course, ito yung sa, yan yung sa globe, the of course, smart, the communication. No, in order to communicate for far distance, electronic devices and systems are used, such as the AM radio, the FM radio, the television, processing, memory storage, display, and then the analysis protection, and etc. Okay, so those are just the applications of electronics. So that's just my introduction. I will now proceed to the dun sa ating course outline, no? So I hope I'll be able to touch all those in the course outline. So we start with the basic terminologies. So first one is that there are the electronic components. There are two types of electronic components. What are these? We have the active components and the passive components. So we start with the active components. The active components, these are the components that requires an external source of power to operate. So examples of these are the transistors, the integrated circuits, the IC circuits, okay, and then the triacs, the LEDs or the light emitting diodes or any diodes, and of course the sensors. This needs external sources in order to operate. And also we have the passive components. The examples of these are the capacitors, the resistors, the inductors, and some few diodes. These do not require an passive components. It should be do not require an external source of power to operate, unlike in active component. So if we are going to differentiate the two, we have the active and the passive components. When it comes to nature of source, the active components deliver power or energy to the circuit. Okay, so they deliver energy. Unlike in the passive component, they utilizes power or energy from the circuit. So ang pinagkaiba, the active component delivers power or energy, and the passive component, they utilize the power or energy from the circuit. So we have, I have given already the examples a while back, and then the function devices for active components. These are the devices which produce energy in the form of voltage or current, like in the transistor, which we will be discussing in a while. Transistor, the purpose of transistor is to amplify signals, no? Amplify weak signals. So from weak signals to greater signals. So that's a transistor, okay? And then the diodes. Then unlike the passive component, devices which stores energy in the form of voltage or current. So that's the difference. For their flow of current, active components can control the flow of current. Okay, and then the passive components cannot control the flow of the current. And then for the requirement of the external source, as I have told you a while back, that active components require an external source for the operation. So it will undergo biasing, wherein biasing means we add external power or source such as battery, okay, such as batteries, okay. Then for the passive, they do not require an external source for the operation. And then for the nature of energy, active components are energy donor. Where am I? Wait. Okay. And then for the passive components, they are energy acceptor. So donor, si active, and then si passive acceptor. So that's the difference between the active and the passive components. Next, guys, we have the, of course, another term that we are going to discuss. These are just basics in electronics, okay? So we just need to have a recap of this. So we have the voltage. Of course, this is the measurement unit of voltage, and we have volts, millivolts, microvolts, and nanovolts. Voltage, wait a minute, okay, voltage is the pressure of electrons or the electromotive force. Hence, the old term here is the E because that is once dubbed as the electromotive force. And given the current and the resistance, the voltage is equal to the current times the resistance. We also have the current. So current is the flow of electrons in a unit time. And the standard unit of current is ampere. Okay, that amps. And then the symbol of current is I. So given guys, V is equal to IR. Therefore, if we're going to solve for the current, that is equal to the voltage divided by the resistance. Okay. So next we have resistance. Resistance, okay, is the measure of how hard electrons
Sir Ariel? Sir Ariel, are you there? I think Engineer Ariel is having a technical problem right now. So we will be waiting for him to come back and continue his presentation. And while we are waiting, again, let me remind you to please register. Can you flash again the QR code and the link? So, ayan. Don't forget to register because our registration will be open until 8:30 p.m. only. Okay? Don't forget to register. Okay, I can see the link. There's the link http://rec.org.ph/element 6 2021 REG. You can also scan the QR code. Kaya register na guys hanggang 8:30 lang, okay? Ayan. So, Engineer Ariel, are you back? Are you there? Okay, it seems like he's still having some technical problems. I can see a lot of you actually came from different areas. So I can see here someone is actually watching from Antique. So hi. And you can also post your comments. We are live via Facebook and YouTube. So, good evening. Hi, Shane. Ayan, so taga saan pa po kayo? So, we can give you a shout out. Ayan. Okay, so yeah, thanks for reminding that doon po tayo nagkaroon ng technical problem sa resistor topic. So, we can also remind Engineer Ariel then. Ayan, so good evening sa lahat and happy Independence Day. Thank you for joining us today. And I hope everyone's having a good time because Engineer Ariel is actually giving us a very informative presentation. So, hi Sir Joel from Manawag, Pangasinan. Wow, hi sir. Ayan. Okay, so while we are waiting for Engineer Ariel, let us hear a few words from our very own engineer Gerhard Pitan. Sir Hard.
Hi,
Hi,
Kasirkel.
sir.
Good evening, everyone. So sorry a while ago, I was on travel and no signal at all. Now I just latched into the restaurant with good signal. But nonetheless, I welcome you all into tonight's event. I hope that you'll be able to gain more knowledge about element 6, and our speaker will be able to share with you a lot of things about this topic. And I wish you all the best for especially those ka-circle who will be taking their exam this coming Friday, and those who will be applying for their exam in the future. Learn from this webinar and experience the best of it. So for tonight, I welcome you again, and let's enjoy, sit back and relax, and learn from this discussion. So again, thank you and good evening, everyone.
Thank you, sir. Thank you po. Ingat po kayo. Ayan, thank you very much, Sir Hard, for that very encouraging and energetic um speech daw. Ayan. So, Engineer Ariel, are you back? Are you there? Ayan, wala pa si Engineer Ariel. So, let's continue to give a shout out. I can see, hi, Floret, Indig Batoktoy from Dalaguete, Cebu. Hi, wow. So, meron pong nagtatanong if the exam is free. So, sagutin po natin ito. Is the exam free? Hello, anyone? Ayan, hintayin po natin ang sagot nila. Paano malalaman ang schedule ng exam? Ayan. Yes, the mock exam is free. So, after the webinar, you will be provided with the link to the mock exam, and that is free. Ayan. Good evening from NCST, from Crystal Clemente Ronario. Pero, yung exam sa NTC ay may bayad. Okay? So, the mock exam is free, but once you take the examination in NTC, may bayad na po siya. Ayan. Okay. About the exam schedule, every Friday po siya nagaganap. So,
Oh,
ayan. It seems like Engineer Ariel is back. Hi, sir.
yes po. Buti na nag-text si Sir Hard. Sorry po.
Ayan, sir. Sir, dun po tayo nag-stop sa resistor topic. Dun po tayo nagkaroon ng technical issue.
Sige po. Sorry, ma'am. Sorry. Ito pala ang StreamYard pag nagpe-present ka na wala ka nang makita solo yung presentation mo, so hindi ako na-aware kung I'm still connected or not.
It's okay, sir. It's okay po.
Sige po. Sir Hard, pag nawawala po ako, paki-chat ulit po ako.
Ayan, sir. So, I will give the floor back to you.
Yes,
And,
ma'am.
ayun po,
Nag-end po
dun
ako
po
sa
tayo sa
resistor, ma'am.
Opo, sa resistor po.
Share. Ito yung mga ngayon, mga problema sa ating mga online,
Yes, sir.
pati sa mga classes, ganun. Ito yung biglang nawawala, ganun kasi, diba, hindi naman natin alam yung kung kailan humihina yung ating internet connectivity, ganun. Sige,
Opo.
pasensya po.
Okay, the floor is back to you, Engineer Ariel. And again, everyone, please listen to our speaker's presentation.
So, sorry again, everyone. And then for the resistance, of course, resistor, from the word itself, resist. This one resists the flow of electrons or the flow of current. Okay? So the greater the resistance, the greater na, the more na hindi makapag-flow ang ating current. Okay? So for the formula, given V is equal to IR, therefore R is equal to the voltage divided by our current. And the capacitor, this is a two-terminal electrical component used to store energy electrostatically in electric field. So capacitor is the one that stores energy. And then we have the inductor. this is like a coil, two-terminal electrical component that stores energy in a magnetic field when electrical current flows to it. So I will check every time yung ating StreamYard, baka biglang nawawala ulit ako. Okay, so we are done with the terminologies. We now look into the etymology of the electronics components, no, yung mga ginagamit natin. So first is that we have the atom. So atom, this is the smallest particle of an element that retains the characteristics of that element. So in the structure of the atom is the basic building block of all the elements. It consists of the central nucleus, ito po yung nasa gitna, of positive charge around which small negatively charged particles. So the negatively charged particles, we have the electrons that are revolving in the different parts of the orbits. Nucleus, this one is the central part of an atom and contains protons and neutrons. The proton, this is the positively charged particle, and it has, while the neutron and the neutron, ito yung no charge, okay? It has no charge. The proton and the neutron, they has the same mass, but the neutron, it has no charge. Therefore, the nucleus is of an atom that is positively charged, okay? So we also have the electrons and the shells. So electrons orbit the nucleus of an atom. So yung sa atom guys, yung electrons may umiikot doon na electrons, okay, per atom. At certain distances from the nucleus. So ang tawag doon, hindi pwedeng may shell lapap ang electrons, may number of electrons per shell, and then meron siyang discrete distance from the nucleus. And there's a discrete energy that exists within the atomic structure. Electrons must orbit only at discrete distances from the nucleus. Okay, this is the shell. So given the atom, so per shell, okay, there are maximum number of electrons that will stay there, that will orbit in there. And the formula for that is that the number of electrons, that is twice, and then the number of shell, the square of the number of shell. So 2n squared, where n is the number of shell. So for example, the maximum number of electrons that can exist in shell 2 is blank. So in shell 2, how many electrons will stay in there? So the number of shell, the shell 2, okay, that is 2, and then squared, that is 4, and then times 2, sa formula natin, 2 times n squared, so 4 times 2, that is 8. So there are 8 electrons in shell number 2, okay? So how many the maximum number of electrons that can exist in shell 4, that is 4 squared, that is 16, times 2, that is 32. And the maximum number of electrons that can exist in shell 5, so 5 squared, that is 25, times 2, and that is 50. Okay, so that is the number of shells that the number of electrons that orbit in each shell. Okay, may mga sobra. Okay, may mga sobra na electrons. For example, kasi certain for example, the silicon, there are 14 electrons, okay? So hindi pwedeng na yung sa third shell niya, hindi niya makukuha lahat yung formula, yung maximum. Kung ano na lang yung natira, okay, na number of electrons doon sa last shell, okay, ang tawag doon is the valence electrons. That is the outer shell electron, okay, that is associated with an atom. And that can participate in the formation of a chemical bond if the outer shell is not closed. In a single covalent band, both atoms in the band contribute one valence electron in order to form a shared pair. We'll discuss that further in a while. We also have the ionization. This is the process of losing a valence electron. So, minsan guys, nawawala kasi yung si valence electron pag lumipad, so from atom to atom undergo ng covalent bonding, meron tayong tinatawag na the positive and the negative ions. So pag nag-lose yung valence electron, pag may lumayas na electron, Okay, nagre-result into positive and negative ions. Okay, and that the process of that is called the ionization. Electrons are equal in number. Hence, if an atom loses an electron, it has lost negative charge. Therefore, the atom becomes positively charged kasi nagbawas siya ng isang electron. And it is referred as the positive ion. If an atom gains an electron, umalis sa isang atom din sa isang atom, and ay umalis yung isang electron sa isang atom and then lumipat sa isang atom, okay? Ngayon, the one, okay, that gains the electron from the other atom, it becomes negatively charged, okay, and it referred to as the negative ion. Okay? Kaya kung may nakikita kayong mga tawag nun, yung example, H plus, H negative, ganun. Okay? Materials, okay, these are the materials used now in electronics. So this is just an introduction for us to diode, okay? So we first, the insulators and the semiconductors. So conductors, these are the one that conductors are the substance that transmits heat, should be transmit heat or electricity through them. Okay, the best conductors are single element materials such as what are these? The copper, the silver, the gold, and the aluminum. The insulator naman, this substance that do not allow heat or electricity to pass through them. Examples of these are the rubber, the plastics. Okay, that means it has high resistance, no? And between them, we have the semiconductor, okay? This can act as conductor as well as insulator under different conditions. So depends on the condition. And this known as the semiconductors. And single element semiconductors, okay, kasi may dalawa. We have the single element and we have the compound. For the single element, these are the arsenic, the boron, the polonium, the silicon, and the germanium. The most known semiconductor is that we have the silicon and the germanium. When it comes to electrons, valence electrons, the semiconductor has 4 valence electrons. For the conductors, it has 1 to 3 valence electrons. The semiconductor, it has 4 valence electrons, and then for the insulators, we have 5 to 8 valence electrons. Okay, so now we have the semiconductor diodes. So mostly that is used in diodes, or what we use in diodes, we use semiconductors. Okay, so I told you a while back that there are 2 types of semiconductor materials, which is the single crystal semiconductors, okay, and the compound semiconductors. The single crystal semiconductors, these are the germanium and the silicon. There are many of them, but the commonly used is that we have the germanium and the silicon. The widely used semicon materials are the silicon and the germanium, and then and then for the compound semiconductors, we have the gallium arsenide. So what is this compound semiconductor? It is constructed of 2 or more semiconductor materials of different atomic structures. So may naganap na bonding. Okay? So we have the gallium arsenide or the GAAS. We also have the CDS, and then the gallium nitride and the gallium arsenide phosphide. Okay, but what we use most is the gallium arsenide, but it's not used most kasi mahal. Though the performance is good, but it's expensive. Okay, that's why they use the silicon, because silicon is abundant in Earth's surface, no? And in numbers of electrons, valence electrons, number of electrons, silicon has 14 electrons, the germanium has 32, and they both have 4 valence electrons that make it semiconductors, no? For the covalent bonding and intrinsic materials, so let's check on this. This is the atomic structure of an atom. Okay, atoms have four valence electrons. If atom has four valence electrons, they are called tetravalent. Okay, so therefore the semiconductors are tetravalent, and those with three, they are called trivalent. From the words tri. Okay, example of that is the gallium. And then those with five valence electrons, they are called pentavalent. Okay, example of that is the arsenic. Okay, so for silicon and germanium, they have both four valence electrons, and that's called tetravalent. And then for the gallium, it has three valence electrons, that's called trivalent. And for the arsenic, they have five valence electrons, that is pentavalent. And then for the covalent bonding of silicon atom, so the sharing of atoms of electrons protonoi, the covalent bonding. So in a pure silicon or germanium crystal, the four valence electrons of one atom form a bonding arrangement with four adjoining atoms. So check mo itong gitna, it has four valence electrons, and then the other silicon, it has four. So nag-sharing sila 1:1. Okay, this bonding of atoms is strengthened by the sharing of electrons, and this is called the covalent bonding. So that is in chemistry. Now we have two types of semiconductors. We have the intrinsic semiconductor and the extrinsic semiconductor. When we say intrinsic semiconductor, okay, the semiconductor is pure, in pure form, walang halo. Okay, example of that is silicon and the germanium. A semiconductor that is in extremely pure form, okay, that is known as the intrinsic semiconductor. Example, the silicon, okay, and the germanium. They are tetravalent, having four valence electrons. They are pure, okay? Pero pag nagdagdag na tayo ng impurity, okay, that is called extrinsic semiconductor. And the process of adding impurity, okay, that is called doping. And a semiconductor material that has been subjected to the doping process, that is now called the extrinsic semiconductor. So example of that is the silicon and germanium added with aluminum and arsenide. Okay? So there are two types. We have the N-type and also the P-type semiconductors. By adding impurities, nakaka-form tayo ng N-type and P-type semiconductor. Okay? The two types of extrinsic or the impure semiconductive materials, we have the N-type and the P-type. These are the key building blocks for most types of electronic devices. Semiconductive materials do not conduct current well and are of limited value in their intrinsic state. This is because of the limited number of free electrons in the conduction band and holes in the valence band. Intrinsic silicon or the germanium must be modified by increasing the number of free electrons to increase its conductivity and make it useful in electronic devices. So let's discuss one by one. So the N-type semiconductor, an N-type material is created by introducing impurity elements that have 5 valence electrons. So those are the pentavalents. For example, the silicon that is it has 4 valence electrons. Magkakaroon tayo, ibaband natin ang isang element that is pentavalent. Okay, these are for example the antimony, the arsenic, and the phosphorus. Each is a member of a subset group of the elements in the periodic table of elements referred to as group 5 because each has 5 valence electrons. So let's have this. The pentavalent, okay, meron sa gitna, antimony, okay, that is in SB, it has 5 valence electrons. Okay, so now, bakit siya naging N-type semiconductor? Kasi, di ba, yung silicon, meron tayong 1 valence electron, may share sa 1 valence electron ng ating antimony. Since there are only 4 valence electron for a silicon, merong isang extra, or that is the 5th valence electron of the antimony. Okay? Pentavalent impurity atom in a silicon crystal structure. An antimony impurity atom is shown, okay, in the center. The extra electron from the antimony becomes a free electron because the pentavalent atom gives up an electron. So si antimony na ngayon is called a donor atom since siya yung nagbigay ng isang free electron. Now, that becomes a n-type semiconductor kasi mas marami na siyang electrons. Okay? Now, from that, in that semiconductor, okay, electrons now are the majority carrier and the holes now are called the minority carriers. And then we also have the p-type semiconductor. The p-type is formed by doping a pure germanium or silicon crystal with impurity atoms naman having 3 valence electrons. A while back, for the n-type semiconductor, we added impurity having 5 valence electrons. For this p-type semiconductor, 3 valence electrons. The elements most frequently used for this purpose are boron, gallium, and indium. Each is a member of a subset group of elements in the periodic table of elements referred to as group 3 because each has 3 valence electrons. So let's check on the structure. So dun sa gitna, we have the boron. Okay? And we know that it has only 3 valence electrons. So magkukulangan tayo ng isang electron. Okay? Now, ibig sabihin nito, pag nag-add tayo ng external energy, pag merong galawan ng electrons, itong boron ngayon, okay, kasi kulang siya ng isang electron, siya ngayon yung mag-a-accept ng electron. So, tawag dito ngayon ay acceptor atom. Okay? Since kulang tayo ng electron, yan ang tinatawag na p-type semiconductor. Okay? So, the holes naman are the majority carriers in p-type material. And conduction band electrons in p-type material are the minority carriers. Okay? Since most of the current carriers are holes, silicon or germanium doped with trivalent atoms is called a p-type semiconductor. That's just in summary. Although the majority of current carriers in p-type material are holes, there are also few conduction band electrons that are created when electron-hole pairs are thermally generated. These conduction band electrons are not produced by the addition of the trivalent impurity atoms. So that is the majority and the minority carriers. Now, we now have the semiconductor diode. In the creation of the n-type and the p-type materials, okay, pag pinagsama natin sila, okay, we now form a diode. Okay, and this one is a diode. So that is, it has 2 regions, the p region and the n region. So this p, this is a p type of material, semiconductor material, and then the n is an n type semiconductor, okay, material. Okay, pinagsama sila, doon nakabuo tayo ng diode. And then the 2 terminals, we have the anode and then the cathode. Okay, so this is the schematic. So this is the symbol, rather. So we have the anode and the cathode. Okay, so si anode, ito yung sa may positive terminal, and then si cathode, ito po yung sa negative terminal. So that is the symbol. So what is all about diode? Diode is used as a rectifier diodes in DC power suppliers. So rectifier, it converts AC to DC. Okay, then it also used as clippers and clampers, also used as switch, and also used as voltage multipliers. Okay, so this is a diode when it has no applied bias. That means there is no external energy. Okay, there's no application of external voltage across the 2 terminals. That means at 0 volts. When we forward bias, so when we bias it, we add external source. That is called, there are 2 conditions. We have the forward bias and then the reverse bias. So, additional of external source. So, maglalagay tayo ng voltage source here. So, we have the anode and then the cathode. When the positive terminal or the anode is connected to the positive terminal of the voltage, that is in forward bias condition. Okay? Forward bias now is, or that is the on condition. For example, that is a switch. Okay, the ideal model, when it is forward bias, it is in on condition. Parang naka-on yung switch natin. Okay, kasi merong tatlong models dyan. That is the ideal model, the complete model, and then the practical model. So, complete model, marami tayong i-consider dyan. Okay, we have basta marami tayong i-consider dyan, but with our discussion, we're going to focus on the ideal, okay? And then we have the practical, and then so practical, we're going to consider the potential voltage or the potential difference of the diode. So if the diode is in silicon, so we are going to use 0.7, and then germanium, that is 0.3. But if it is in ideal model, forward bias, that is on, okay? On condition. And then pag reverse bias, okay, the negative, okay, the negative terminal of our, okay, the negative terminal of our voltage source is connected to the positive terminal of our diode. Okay, that is in reverse bias. Okay, the negative terminal of the source is connected to the anode side of the circuit, and the positive terminal, or that is the and the positive terminal is connected to the cathode, or that is the negative terminal of the diode. Okay, a resistor is not necessarily in reverse bias, but it's the circuit consistency. The reverse current is extremely small, or that is what we call the leakage current, and can be considered to be zero. Okay? So, pag ganito, pag reverse bias in ideal model, pag reverse bias condition ng ating diode, that is off. And then there are many types of diodes. Okay, but I'm going to discuss only few of these. These are the different types of diodes. We have the small signal diode, the large signal diode, the Zener diode, the light emitting diode. Ito yung pinaka-famous sa atin, the light emitting diode, kasi lahat tayo gumagamit na ng light emitting diode. Okay, the constant current diodes, the Shockley diode, the step recovery diodes, the tunnel diode, the varactor, the laser diodes, transient voltage suppression diode, the gold dope diodes, the super barrier diodes, and so on and so forth. These are this, okay, up to the GaN diode. And every diode class, okay, they have different notations or symbols. So this junction diode is the basic diode symbol. And now we have this, the Zener diode. So Zener diode, parang may letter Z, the tunnel diode, the Schottky diode, the varactor diodes, okay, the diac, triac, the SCR or the silicon controlled rectifier, the light emitting diode or the LED, okay, and then the photo diode. Okay. So I just chose few diodes to explain, and these are most used diodes. Okay, or the famous diodes. The Zener diode, this acts as a voltage regulator. So the most application of this Zener diode is in the power supply sa may regulator side. This is what is the difference between the junction diode? Diba, ang junction diode natin is operates when it is forward bias. For Zener diode, this is a heavily doped semiconductor diode which is designed to operate in reverse direction. Okay, Zener diode operates in reverse direction. Next one is the light emitting diode. These are the diodes that convert the electrical energy into light energy. So LEDs as the main source of lighting in homes, offices, streets. Okay, these are used for street lighting as well as the traffic lights. It also used in the automobiles and the mobile phone. So we are using LED. Okay? LED kasi is ano na, pero dati ang LED is very expensive, but now very economical na siya, no? So that's why we are using the LED na. And then, syempre, mura sa pag-consume ng current. Schottky diode, these are used in high-frequency rectifier applications. In this type of diode, the junction is formed by contacting the semiconductor material with metal. Due to this, the forward voltage drop is decreased to a minimum. The semiconductor material is N-type silicon, which acts as an anode, and metals such as the chromium, we also have the platinum, we also have the tungsten, okay, wherein they act as a cathode. We also have the tunnel diode. Okay, what are the applications of the tunnel diode? Okay, we have oscillatory circuits, we have the microwave circuits, and resistant to nuclear radiation. Okay, this is used as high-speed switch with switching speed in the order of few nanoseconds. Due to the tunneling effect, it has very fast operation in microwave frequency region. It is a two-terminal device. Of course, we have the negative and the positive, in which concentration of dopants is too high. We also have the varactor diode. Okay. The varactor diode, this is also known as the varicap diodes. So from varicap or the varactor diode. It acts like the variable capacitor. So kaya nga naging varactor, variable capacitor. Operations are performed mainly at reverse bias state. These diodes are very famous due to its capability of changing the capacitance ranges within the circuit in the presence of constant voltage flow. They can be able to vary capacitance up to high value. In varactor diode, we can decrease or increase the depletion layer by changing the reverse bias voltage. So what are the applications of the varactor diode? It is used as voltage-controlled capacitors, voltage-controlled oscillators, the parametric amplifiers, the frequency multipliers, FM transmitters, and phase lock loops in radio, television sets, and cellular phones. So this is the symbol for a varactor diode. So makikita nyo, parang capacitor ito, okay? Yung sa cathode side niya. Okay? So meron tayong last na example. We have the SCR or the silicon controlled rectifier. This consists of 3 terminals. So unlike the previous diodes, they are composed of 2 terminals, only the anode and the cathode. For the silicon controlled rectifier, it has 3. So an addition of gate. So it consists of 3 terminals. So the anode, the cathode, and the gate. Okay, it is nearly equal to the Shockley diode. As its name indicates, it is mainly used for the control purpose when small voltages are applied in the circuit. Okay, that's for the diodes. Now, we have the DC power supply naman. Basic DC power supply. So, meron po tayo nitong stages dito. So, ito yung composition ng ating basic DC power supply. We have, so from the AC circuit, okay, so papasok siya ngayon sa ating transformer, okay, and then ang output ng transformer, we're going to talk this one by one, no? So there are, we have this transformer, the rectifier, the filter, the regulator, and the load. So, applications ng mga ating diode ay makikita natin dito. So first, we have the transformer, this one, okay? So the transformer is defined as a passive electrical device that transfers electrical energy from one circuit to another through the process of electromagnetic induction. It is most commonly used to increase or step up or decrease or step down voltage levels between circuits. So with the use of this, with the number of coils, okay, we have the 1,000 turns and the 500 turns. So depends po dun sa need ng ating need natin, okay? So either it steps up, so from the 120 volts, 60 hertz AC, kung konti lang yung kailangan natin, we need the high the primary winding should be greater than the secondary winding. So ang mangyayari doon, it will step down. If the number of windings, okay, in the primary winding is greater than in the secondary winding, magi-step up, ay lesser than pala yung sa ating primary winding, tapos mas madami sa ating secondary winding, doon nagaganap yung ating step up. Okay? So, sabi dito, changes AC voltages based on the turns ratio between the primary and the secondary. And then, we have the rectifier. So, pag pumasok na siya sa ating transformer, still AC pa rin po ang lalabas doon, only that, nag-step up or nag-step down. And then, the next stage is we have the rectifier. It is an electrical device that converts alternating current, which periodically reverses direction to direct current. So, from AC current to DC, alternating current to direct current. So from AC to DC, that is the purpose of rectifier, which flows only in one direction. Kasi pag AC, magulo pa siya. Okay? And then pag we rectify it, medyo maayos na siya. However, it needs to be filtered more. Okay? Kasi nagka-fluctuate pa yung ating signal. So what we do, meron tayong filter. In the filter, it eliminates the fluctuations in the rectified voltage and produces a relatively smooth DC voltage. So, nagiging smooth na siya until it goes to the regulator. Now, it maintains, sa regulator, it maintains a constant DC voltage for variations in the input line voltage or in the load. Regulators vary from single semiconductor device to more complex integrated circuits. So, when it is regulated, so parang naging smoother siya sa ating filtered and then more naging DC na siya na regulated voltage bago pupunta sa ating load. And the load is a circuit or device connected to the output of the power supply, okay, sa power supply natin, and operates from the power supply voltage and the current. So, from this, after the transformer, we focus on the rectifier circuits. So we have the rectifier circuits. For this, if we're going to discuss this one, it needs how many sessions in the undergrad, no? But because we have only, this is like this a recall of everything, a recap of everything. So medyo giving of introduction and some basic concepts of this na lang po, no? So we have the rectifier circuits. There are types of rectifier circuits. So we have the half-wave rectifier. For the half-wave rectifier, ibig sabihin po, given one cycle, okay, this is the half-wave rectifier. Okay, so it has a peak, and then during the positive half cycle, okay, doon lang po siya nagkakandak, and the next negative half cycle, hindi na po siya nagkakandak. Kasi during the positive cycle, okay, the input, the input voltage is connected to our anode. That means that is forward bias. Therefore, our current is flowing. And during the negative half cycle, kasi half-wave rectifier natin siya, the negative voltage, the negative terminal of our input voltage is connected to our diode. That means it is reverse bias, therefore it is open. Ibig sabihin, hindi na siya nagkakandak into the next half cycle. Okay? So, as an output, from time 0 to time 1, okay, that is the input voltage, that is during the positive half cycle. Okay, during the positive half cycle, it is conducting. Okay, sa output natin. And during the negative half cycle, it is reverse bias. That means it is open. So the current cannot flow. Ibig sabihin, yung voltage natin is equal to 0. Okay? During the positive alternation of the 60 Hz input voltage, the output voltage looks like the positive half of the input voltage. The current path is through ground back to the source. We also have the transformer coupling. Okay? Transformer coupling provides two advantages. First, it allows the source voltage to be stepped down as needed. Second, the AC source is electrically isolated from the rectifier, thus preventing a shock hazard in the secondary circuit. Okay, so Sabi ko nga kanina, there's a relationship between the primary winding and the secondary winding. So that is the N prime and then the N secondary to the voltage, the primary voltage and the secondary voltage. So here we can have the primary voltage and then this one will have the secondary voltage. Wherein, if we're going to evaluate this one, the secondary voltage now will be the input in this side towards our output voltage. Okay? So the relationship between the two is that the secondary voltage is equal to the ratio of the primary winding and this the secondary winding and the primary winding times the primary voltage. So N is equal to the secondary winding all over the N prime. So the amount that the voltage is determined by the turns ratio of the transformer. A transformer with a turns, okay, yung mas mababang ratio, okay, ibig sabihin less than 1, is a step down type. Okay. And then the one with turns greater ratio greater than 1 is a step up type. Okay? So, not this one. We also have this, the full wave rectifiers. Okay, for the full wave rectifiers, this allows unidirectional or the one-way current through the load during the entire of the input cycle. Whereas a half-wave rectifier allows current through the load only during one half of the cycle. Ibig sabihin guys, from the positive half cycle and the negative half cycle, tuloy-tuloy po siya. Okay? Hindi po siya mag-zero sa ating output. And one of it is we have the bridge network. Where in the bridge network, it uses 4 diodes. Bakit po siya tuloy-tuloy? Okay, let's check. During the positive half cycle, so meron tayo from 0 to yung half ng ating cycle. So half ng ating period is 2/2. During the positive half cycle, okay, the positive terminal of our voltage ay connected sa ating sa D1 that is reverse bias, therefore si D1 is mag-o-open. And then, si D2 is masya-short. So, there's a flow of current. Okay? And then, tong negative terminal na input voltage ay connected sa ating D4. Therefore, si D4 is mag-open. And then sa D3 that is forward bias, that means shorted, so the current can flow through it. So during the positive half cycle, nakakadaan pa rin yung current natin. So from D2, so output voltage natin is dadaan sa D2, D3. Okay, so meron tayong output voltage. During the negative half cycle naman, so babalik na rin natin, si negative connected siya ngayon kay D1. Kay D1, okay, forward bias, and then kay D2, that is reverse bias, that means mag-open si D2 naman. And then sa ating resistance, that is the output voltage, and then so negative, positive na dito sa baba during the next half cycle, si positive connected siya sa anode ni D4, and then connected siya sa cathode ni D3, therefore that is reverse bias, so mag-open to, so dadaan yung current natin from D1 to D4. Ibig sabihin, continuous yung kanyang flow. So, ito pala yon, no? Sorry. So, positive, negative, during the positive half cycle, mag-off si D1, mag-on si D2, okay? And then, mag-off si D4, kaya dadaan yung current natin this way. So, ibig sabihin, from 0 to time 2, meron tayong voltage. Okay? Meron tayong peak voltage. And then, during the negative half cycle naman, so, babalik na rin natin yung orientation ng ating voltage source. So, negative. So, it will, before, magpo-forward bias siya dito sa part na to, the diode here. And then, open sa kabila. Pero, meron pa rin siyang dadaanan, continuous siya. Okay, so from the half of the period up to the end of the period, tuloy-tuloy siya. Okay, so kaya sinawag siyang full wave rectifier. We also have the center top transformer. This is a type of full wave rectifier that uses only 2 diodes. Diba yung full type rectifier kanina sa bridge type, gumamit siya ng 4 na diodes. For this, gumamit lang siya ng 2 diodes that are connected to the secondary of the center top transformer. Okay, the input voltage is coupled through the transformer to the center tap secondary. Half of the total secondary voltage appears between the center tap and each end of the secondary winding. So this is the orientation of our center tap transformer. Okay, so that is for rectifier circuit. Okay, another topic is that we have the transistors. For the transistors, okay, this is a semiconductor device with three connections. So, ayan, three connections. So, mayroon tayong two types. We have the BJT and the FET. So, bipolar junction transistor and the field effect transistor. It has three terminals and three regions. Okay, so these are the example of transistors. So it's used for rectification. It's also used in amplification. So transistor from the transform weak signal to transforms weak signal. It amplifies weak signals. Okay, well, so for the first transistor, sorry, just a short history of transistor. We have John Bardeen, Walter Brattain, and William Shockley that invented the first working transistor at Bell Labs. Ang tawag doon ay the point contact transistor. Naman guys, it's very big, no? Kung hindi yan nagbago ngayon, 'di ba? Transistors now are very small, okay? Kung hindi yan nagbago ngayon, ganyan kalaki. So ilagay mo sa cellphone mo. So ano kayang itsura ng cellphone natin ngayon, no? Kung ganyan kalalaki yung transistor ngayon. So thanks to technology nanotechnologies, no? So Shockley introduced the improved bipolar junction transistors in 1948. Which entered production in the early 1950s and led to the first widespread use of transistors. So, as I told you a while back, there are two types of transistors. We have the bipolar and the field effect transistor. So, for the BJT, we have the bipolar junction transistor. The BJT, this is one type of transistor that uses both majority and minority charge carriers. Kaya sa tinawag na bipolar because it uses both majority and minority carriers. So dalawa siya, kaya bipolar. And then, it's better to, I will show you the figure in a while. No? Then these semiconductors devices are available in two types. Okay? So what are these? So we have this, the PNP type and the NPN type. So, ang dating ng transistor, guys, is that, di ba, we have diode, parang two diodes na pinag-combine, pinagsama back-to-back. Okay? Di ba, ang diode is we have the P-type material and then the N-type material. So, pag dalawa yung pinag-back-to-back, for example, this is a PN, then another PN. Okay? One diode, then another diode. So, PN-PN diode, pinag-combine natin siya back-to-back. Okay? Kaya si N, nagsama together. Kaya P, N, P. Okay? So, parang two diodes. Now, sa PNP, by the way, a transistor, okay? A transistor can be used as switches and amplifiers. Okay? Applications of BJT involve wide range that includes electronic devices like TVs, the televisions, the mobiles, the computers, the radio transmitters, the audio amplifiers, and industrial control. So for the two types, we have the PNP and the NPN. So sabi natin, there are three terminals. Okay, so three terminals. So we have the collector terminal, the base terminal, and the emitter terminal. And parehas lang po yung PNP and NPN. Only that in PNP, si N ay na-sandwich between two P-type materials. Okay, for the NPN, so that the P-type material is sandwiched by two N-type materials. Okay, semiconductor materials. So sa schematic, sa symbol nito, so yung letter T, so pag mag-drawing ka, para mag-drawing ka muna ng letter T na pahiga, so that is the base, and then the collector, and then the emitter that the arrow goes to the transistor. Okay? Ibig sabihin, I is goes there. Para hindi ka malito, PNP, ibig sabihin, papasok yung symbol na emitter kasi yung current later dyan, the emitter current, IE, okay, papasok, ang tawag na doon is parang pasok na pasok. Okay? For NPN, palabas yung arrow, nakapasok na. So, NPN. Okay? So, the main difference between the PNP and the NPN transistor turns on, okay, is that an NPN, okay, transistor turns on when the current flows through the base of the transistor. And the PNP transistor turns on when there is no current at the base of the transistor. In this transistor, the current flows from the emitter to the collector. Okay? So we have the current IC kasi dito, the current that is flowing sa may collector region, that is the collector current. And then the current that is flowing through the base region, okay, that is the base current. And then the current that is flowing through the emitter region, that is the emitter current. So pagpababa to guys sa NPN region, so sa KVL rule natin, di ba, lahat ng current na papasok ay equal sa summation ng current na palabas. So ibig sabihin class, kung papasok si current collector, papasok si base current, okay, and then palabas si emitter current, therefore IE now, so papasok sa dalawang collector, di ba, equal yun sa summation. So pareha, ang papasok na current ay equal sa summation ng palabas na current. So kung palabas sa emitter, papasok si current ni collector and base, i.e. now, the emitter current is equal to the sum of the base current and the collector current. Okay? So IE is equal to IB plus IC. So when it comes to size and doping, so ito po yung size and doping, no? So sa drawing dito, we have the emitter. So very manipis lang po si base region and then si collector region. Okay? When it comes to doping, okay, what do you mean by doping again? The additional of extrinsic, okay, yung additional of impurity. Okay? So si base, that is very light. So that means yung size niya is very thin. Si emitter is strongly doped. And then the collector, when it comes to size, the collector is the largest one. Okay? But when it comes to doping, moderately doped lang siya. Okay? Therefore, when it comes to width, the collector is greater than the width of the emitter and the greater than the width of the base. And when it comes to doping, the emitter is greater than a moderate, the emitter is strongly doped. So compared to our collector, which is moderately doped, and the base is a lightly doped. So yan po yung sa size ng ating transistor. And then when it comes to operation, so meron akong small drawing here. Sorry. So we have the NPN. So there are two junctions. Okay, the junction 1 and the junction 2. Pag maglagay tayo, di ba, sabi kasi natin that is composition of two diodes. Okay? So pag maglagay tayo ng voltage source, okay, one in which one is forward bias and then the other one is the reverse bias. So forward bias natin itong isang external source, so the positive terminal, the negative terminal is connected to N. Di ba? Pag forward bias is N to N, P to P. And reverse bias, pag N to P, okay, negative terminal to positive, okay, that is reverse bias. So when forward bias, ito, so the negative terminal is connected to our N, and then the other one, the positive terminal is connected to our N. That means that is reverse bias. So, ang sabi natin dito, class, when junction 1 and junction 2, so junction 1 is the junction between the N and the P, and then the junction 2 is the junction between P and N. That's why there are two junction. Kaya bipolar junction transistor, and transistor is a family of resistor, and sabi nga natin transistor is to amplify weak signals, therefore it transfers, di ba? So transfer resistor, kaya transistor. Okay, transfer resistor, transistor. Okay, bipolar because it uses the two majority carriers, the electrons and the holes, kaya bipolar siya. And then junction because it has two junctions, the junction 1 and the junction 2, and then transistor. Transistor. Okay? When sa NPN, when it's forward bias, when junction 1 is forward bias and the junction 2 is reverse bias, the region of that is inactive, okay, operation, and it acts as amplifier, okay, and it acts as amplifier. When the both are forward bias, the two junctions are both forward bias, it is on the region of saturation, wherein that is in on, okay, on siya or closed switch. When kasi sa una, okay, forward to and reverse bias, it acts as amplifier. Okay, and the next two, the transistor acts as a switch. Okay, so when the junction 1 is reverse bias and the junction 2 is also reverse bias, that is in the cutoff region or off. Okay, bakit siya off? Kasi open circuit. Okay, open circuit, walang makapag-flow ng current. Okay, and when it is reverse bias, the junction 1 is reverse bias, and junction 2 is forward bias. It acts as inverter, which this is rarely used. Okay, in transistors, we also have the current gains, wherein it is dubbed as the alpha and the beta. So sabi natin, there's a current that is flowing from the transistor. We have our BJT, we have the collector current, the emitter current, the base current. Okay, for the alpha, that is the ratio of the collector current and then the emitter current. And for the beta, that is the ratio of the collector current and the base current. Okay, so if we're going to parang manipulate it further, we can have IC, which is equal to your alpha IE, okay, and then IC is also equal to your beta IB by cross multiplication, no? Then as alpha now is equal to beta all over beta plus 1, and beta, okay, in relationship with the alpha, that is equal to alpha all over 1 minus alpha. Magagamit natin ito in solving yung meron tayong configurations kasi in BJT. We have the fixed bias configuration, we have the emitter. Okay, we have different configurations wherein magagamit natin lahat ng mga formula na ito. Okay? And then, so, ang BJT is malawak yan. Okay? It has a very wide scope. So, ito lang yung mga parang sinabi ko lang sa mga applications niya and some important formula na kailangan nating makita, and of course the other concepts, no, na pwede nating malaman for BJT. Pero ang BJT is very wide. If I'm going to discuss it today, baka abutin tayo ng 10 o'clock. Okay? So we also have di ba sabi ko kanina, there are two types of transistors. We have the BJT and then the FET. So we have this, the field effect transistor. So sa BJT kanina, we have the base, the regions base, the emitter, and the collector. For the field effect, okay, we also have the N channel and the P channel. And the terminals here, we have the gate, the drain, and the source. Okay? The term FET, that is the field, okay, yung F, and then effect, and then the transistor, that is a FET. It is also named a unipolar transistor. FET, this is one of type of transistor where the output current, okay, is controlled by electric fields. The basic type of FET is totally dissimilar from BJT. Okay, if you look into the differences of the two, okay, we can say that FET is better than BJT. Okay, FET consists of 3 terminals. Okay, like in the BJT. So in BJT, yung sinabi ko kanina, we have the collector, the emitter, and the base. For FET, we have the drain, the source, and the gate terminals. The charge carriers of this transistor are the holes and the electrons. Same with the BJT, which flow from the source. So from here naman, from source to drain terminal via an active channel. This flow of charge carriers can be controlled by the voltage applied across the source and gate terminals. Okay? So kanina doon sa ating BJT, that is the PNP and the PNP and the NPN. For the FET naman, we have 2 types still. We have the JFET or the MOSFET. So for the JFET, this is the junction field effect transistor, okay? And the field effect, or the MOSFET, or the metal oxide semiconductor field effect transistor, or that is the insulated gate field effect transistor. Okay, that is most known as the MOSFET. Okay, metal oxide semiconductor field effect transistor. Okay, so if you're going to compare the two, when it comes to what kind of controlling device are they? So BGT is a current controlled device, while FET, guys, is a voltage controlled device. Okay, so I'll end my discussion in there, but I prepared few questions for us to practice. Okay, in order to emit light, LED or the light emitting diode must be A, forward bias, and then B, reverse bias. So that is a light emitting diode. So that is a diode. Di ba sabi nga natin kanina, when it is forward bias, we allow the current to flow. Okay? That means it turns on the diode. So therefore, in this, the answer is forward bias. And then, number two, the Zener diode serves as a good simple voltage reference because it maintains a relatively constant voltage across it when A, forward bias, B, reverse bias. So that is Zener diode. Okay, di ba sabi natin kanina na there is a difference sa Zener diode, medyo different siya sa ating junction diode, di ba? Because in Zener diode, sabi natin, okay, it is designed to operate in reverse direction. Therefore, the answer here is reversed bias. Review na. So, which of the following components should be added to an existing resistor to increase its resistance? So, for resistor, okay, when it is series, so another resistor plus another resistor, if you're going, if it is in series, the equivalent resistance or the total resistance of it, okay, you just add them. Okay, you add them. And in parallel, parang meron kang 1 over R1 plus 1 all over R2, tapos 1 inverse of it. Okay? So that is in parallel. So mas liliit yung value niya. So the question is that, para i-increase natin yung resistance, anong gagawin natin sa ating resistor? Okay? So we add another resistor in series. Kasi pag in series resistor, you are going to add it. You add them. Okay? So ibig sabihin, when you add them, nag-i-increase ang ating resistance. And then, next question. To forward bias a diode. Okay? A. An external voltage is applied that is positive. Okay, external voltage is applied that is positive at the anode and negative at the cathode. So the positive terminal is connected to the positive to the anode, and then the negative terminal of the external voltage is connected to the cathode. B. The external voltage is applied that is from the negative to the anode. Okay, so mali na siya. B is reverse. So C, an external voltage is applied that is a positive at the P region. Okay, the P region is sa may anode. Okay, and the negative at the N region, so may cathode. So same lang C, A, and C. That is how to forward bias a diode. And then we have what are the three terminals of a bipolar junction transistors? Okay, so A, B, PNP, BJT po to ha, the B, NPN, C, input, output, ground, and then the B, we have the base, emitter, and the collector. Okay, so PNP and the NPN, those are the two types. Okay, and then input, output, ground. But we are talking about the terminals of a BJT. So we have the base, the emitter, and the collector. So the answer is letter D. Okay? In a PNP transistor, okay, ano ang regions meron kay P? So PNP, di ba, we have connected sa P is the emitter, N is the base, and then the P is the collector. So ibig sabihin, we have the emitter and the collector. And that is letter C. Okay? Kasi base po yung nasa gitna. Next, the drain, source, and gate are the terminals of what kind of transistor? BJT or FET. So, ang BJT, that is the emitter, the collector, and the base, and then the FET, we have the drain, source, and the gate. So the answer is letter B. How many terminals does a diode have? So for a diode, we only have the cathode and the anode. Okay? So the answer is 2. And then for transistor, that is 4, 3. How many valence electrons does a conductor have? Diba sabi natin kanina, we, different types of materials. We have the conductor, the semiconductor, and the insulator. For a conductor, it has 1 to 3 valence electrons. For the semiconductor, it has 4 semiconductors. And then for the insulator, it has 5 to 8 valence electrons. Okay? So for a conductor, we have 1, 2, 3. 4 is for semiconductor, and then we have 5 to 8 for the insulator. And then last one, what do you call to the elements that have three valence electrons? Tetravalent, pentavalent, or trivalent. So tetravalent, these are the semiconductors because it has 4 valence electrons, and then the pentavalent, these are the the semiconductors or that have 4 valence electrons. So these are semiconductors. Okay, so tetravalent and then pentavalent and then the trivalent. These are semiconductors that has 3 valence electrons. So the answer here is trivalent. So with that span of time that I talk, I hope I was able to share something on you. So thank you so much for your participation.
Sir Ariel, thank you so much for that very
Yes,
informative
ma'am.
presentation. It was actually a good refresher of my circuit components class in college. And I think they listened well because I am seeing all the correct answers po dun sa ating comment section
Ah,
when you ask the
nice.
questions. So, good job, guys. And thank you, Engineer Ariel, for being our amazing teacher today. Ayan, but
Welcome
I think
po.
hindi pa po tayo tapos dahil our viewers might have some questions or clarifications about the presentation because later on they'll have the mock exam. So baka meron po tayong mga questions dyan. So we are now moving on to our Q&A portion. So guys, we are encouraging everyone to post in your questions on the comment section. Ayan. So, Engineer Ariel will answer them. Ready na po ba kayo, sir? Ayan na.
Please lang
Please
kung
give.
madaming tanong ma'am is isend nyo na lang sa akin then I will send back on you para masagutan natin lahat.
Ayan po.
Sumasakit na yung throat ko.
Ayun lang. Ayan,
Ah,
sir. So, meron po ba? Meron po bang magtatanong? Sir, I believe wala pa po tayong pumapasok na question and that is a good thing because lahat po ng mga katanungan nila ay nasagot during the presentation. It is very
yeah.
informative. Ayan po. Saka
Thank
tama
you
yung mga
po.
sagot nila, amazing talaga.
Ah,
Tinitingnan ko po dun sa comments. Ayun, so nakakatuwa din po. So, I think wala po tayong questions. And if meron pa kayo, just post in on the comments and we will send it to Engineer Ariel para masagot niya yung mga katanungan niyo, okay?
yes po, better.
So, ayun po. Sir, kumusta naman kayo ngayon? Okay naman po ba?
Dito sa Tugigaraw, aside sa sobrang init pa rin dito, nasa MECQ pa rin kami dito. So
Oh,
until 15, pero waiting kung mamumove na naman hanggang katapusan yung ating MECQ dito. So ano kami, work from home, pero pumapasok pa rin kami sa school parang once a week, ganun po. So
okay
lahat
po. Basta
online
ingat
katatapos
lang
ng
po.
final exams.
Mhm.
Lahat po tayo,
Opo.
sa lahat po ng nanonood, mag-ingat po tayong lahat. Health is wealth po, no? So, kung pwede mag-stay at home tayo, stay at home. Kung wala naman tayong kailangang puntahan sa labas, so wag na tayong lalabas. Okay, tulong tayo sa sa pag ano ng COVID na to. Ang hirap ng ating sitwasyon ngayon. Pero of
Opo.
course, kakayanin natin.
Opo. Thank you po, Sir Ariel. Sir, baka po gusto niyo silang i-encourage na manood ng inyong vlogs? Ayan.
Hindi, ano lang po yun, puro kalokohan lang po yun sa vlog ko na yun. Oo. Oo. So meron po akong YouTube channel, Master Ariel. So check nyo lang po yung Master Ariel. Pero I'm planning po na by this coming short term, the transition or the next semesters, mag-ano ako ng mga calculator techniques, ganun po.
Wow.
Mag-vlog po ako ng mga calculator techniques para sa mga engineering students natin, ganun po. So,
Ayan, guys.
follow
Watch
me.
out. Lalo-lalo na dun sa mga magbo-board exam, yung mga nasa college
Yes po.
ngayon, yung mga mag-e-exam for NTC, ayan. So, watch out for Engineer Ariel's, Master Ariel's vlog for calculator techniques. O, di ba? Ang
Yes
bongga
po.
nun. Ayan. So, I think, ayan, meron pong nagtatanong, sir, lumalabas po ba yan sa NTC licensure exam?
Sa NTC licensure exam, based po yun sa binigay sa akin kanina ma'am na ay tawag nun, based dun sa laman ng ating element 6 wherein meron siyang sample questions, composed po yung BJT and FET po doon. The diodes, lahat po yun, the BJT and the FET. So kasali yun sa dun sa content ng ating element 6 po. So lumalabas
Ayan.
po siya sa ating exam. So, may haha si sir, masayahin siya, pares tayo. Every time na mag-chat din ako, maraming haha. Ay, Girly Ocampo. Hi, Girly.
And ayan, yan po kay Girly Ocampo. Speaking of BJT and FET, may applications po ba na combination ng BJT and FET? Curious lang po, haha.
Sa combination ng dalawa, sa advanced na po yon. So, magko-combine po sila doon. Pero, usually po, hindi, bale, ibang ano na yon, iba na yung equivalent nun, okay? Pag yung mga pinagsama-sama yung BJT and FET kasi they have different applications po, the BJT and the FET.
Ayan. So, any more questions? I think, wala na pong mga nagtatanong. Again, thank you so much, Engineer Ariel, for sharing your knowledge to us.
Thank
Ayan.
you din po.
On behalf of Radio Engineering Circle Incorporated, we would like to thank our speaker, Engineer Ariel Lorenzo, for joining us this evening and allotting time for us to impart his knowledge about amateur radio practice. We sincerely appreciate po, sir.
Thank you po.
Yun. Ayan, so don't leave yet and wait for the link to the mock exam. Ayan, so, and also, again, we invite everyone to be a member of the Radio Engineering Circle. Just follow the instructions on your screens. Ayan, log on to rec.org.ph/join. So, join na, mga ka-circle. Ano pang hinihintay nyo? Okay? And I've mentioned earlier that this is a 3-part series. So watch out for the next episodes to be posted on our Facebook page. Just like and follow our page. facebook.com/rec.org.ph. Please like and follow our page. Ayan. So may mga pumapasok tayong questions. Don't worry guys, we will get them all and send them to Engineer Ariel para masagot ang inyong mga questions.
Doon pala din
Yan.
sa nagtanong nung ma'am, nung combination ng BJT at saka FET, yung pag pinag-combine mo yun is tawag na doon is BiFET. Okay? So, yun po yung combination ng dalawa.
Ayun. BiFET. Oo nga, na-recall ko yan, sir. Ayan. May practical application po. Sir, pwede pa pong magpahabol ng isa? May practical application po ba ang mga superconductor? Ayan. Magandang katanungan.
Lahat po, meron pong practical applications po. Okay.
Oh. Ayan.
Oo.
So, lahat.
Pero for the specific application of it, okay, so,
sir, I think, Sir, are you there? Ayan, nagkaka-technical problem po tayo ngayon. Meron po tayong katanungan. Pwede po ba akong mag-join kahit wala pa akong license? Sabi ni JD Maapi. Pwede po. Ayan. Kayong
Nawala ako. Sorry, nawala ako.
Ayan, sir. I think ako din po. Medyo na-disconnect ako for a while. So, meron po nagtanong kanina if pwede daw po ba silang mag-join kahit wala pang license. So, ayan, pwede po.
Pwedeng-pwede po. Kasi hindi siya required ng license to join the NTC exam po.
We would like to invite you to join Radio Engineering Circle Incorporated. Just log on to rec.org.ph/join to apply. Again, we are a proud member of Philippine Amateur Radio Association and Federation of Rapid Emergency Telecommunications Team of the Philippines. Ano pang hinihintay nyo? Join na at maging ka-circle na. Ayan. So, ang start ng ating examination would be at 9 p.m. So, please wait for the link of the mock exam. 9 p.m. po ang start niya, okay? Huwag muna kayong aalis so you can take the mock exam. And also, don't forget to answer the feedback form. Pwede po ba natin ipakita ang link sa ating feedback form or mamaya na? Ayan, yan po ba yun? Ayan. You can access the link on or before 6 p.m. Ayan, of June 13, 2021. So hanggang bukas sila pwedeng mag mag-provide ng feedback. Tama po ba? Ayan. Don't forget to answer the feedback form, guys. And let's move on to our closing remarks. Ayan, to give us our closing remarks, may we call the Vice Chairman of the Radio Engineering Circle, PECE ASEAN Engineer Master Ornan Vicente. Sir Ornan. Oh, okay. So, we were just informed na uh, si Engineer Hard po ang magbibigay sa atin ng ating closing remarks. Ayan. Sir, so Engineer Hard Tan, may we have a few words for our viewers na mga masugid na sumubaybay sa atin ngayong gabi. Ayan.
Hi, here with me again, and thank you everyone for attending this session with Engineer Ariel. I wish that you had learned a lot from this session tonight, and I look forward seeing your name in the NTC list that you will be passing your exam for Class A or Class B or Class C or Class D. So depending on which level you are applying. So tonight, it's a great moment with Engineer Ariel as he was able to explain really the different concepts pertaining to Element 6. And even me, I was able to grasp a lot of things and learned again the basics of electronics. So tonight, hope that everyone is safe. And from this, I wish you a good luck in your exam in a short while. Make the most out of it and be the best from the class. So again, good evening everyone and take care.
Thank you po, Sir Hard. Ingat din po. Ayan. So, again, everyone, the examination will open at 9 p.m. pa. So, we will be posting the link, but it will be open at 9 p.m. I can see that they say that the exam sheet has no content. It's because it's gonna be available at 9 p.m. pa. Okay? Ayan. So, thank you for attending today's webinar. I know it's late, and thank you for giving us time So I hope madami kayong natutunan, and let's just wait until 9 p.m. para sa link, okay? So kindly fill out the feedback form and mock exam by logging onto the link to be flashed on your screen. This will be the prerequisite for your e-certificates, so please do not leave the session without completing the examination. Okay? And we are looking forward to see you again next week. This is your host, Christine Bendo. Have a great weekend and good luck on the exam. Stay safe, everyone. 73.